All right, y'all, I'm going to try and record this video here at home. I'm just going to set your expectations because you know I have feelings. This is marker. My table is clean. It's just, you know, Molly, she likes to draw on it with the Mr. Sketches. Anyway, none of that matters. Anyway, so we're starting our new unit on bivariate data and scatter plots, and I wanted to make sure that you had some solid notes, so here we go. I hope the sound is good. I hope it's loud enough. I got what I got. I got my teacher camera, which is not the school's, so whatever, I'm done justifying myself. Okay, so this next unit is going to be about bivariate data and scatter plots. So first thing we want to talk about is like, what is bivariate data? Okay, so bivariate data is real world data. So what we're looking at is how do two things relate to each other. So like, here's just some examples of bivariate data. Hours that you work and money you earn. Age of a child, shoe size. Cold days, hot chocolate. Miles driven, gas sold. So two things. They don't have to necessarily like seem related. Like, I'm always eating carrots in class. Some people say, oh, Miss Deal, is your vision good because you eat carrots? Those two things are correlated, but we're going to talk in a minute about causation. So those two things, people think that they are related. Like I'm looking out my window right now, which I wish I could show you. Which I guess I kind of can. I have this giant tree in my backyard which is growing like mad because it's rainy. Okay, so like there's a correlation between the amount of rain and the amount of tree growth. So there's correlations, and that's how two things co-relate. So co means with, there's a Latin root, it means with, and relate means related. So they're related with each other. Bivariate means two variables. Okay, so when we look at data, okay, we could have data that these two data sets could move in. They can move in the same direction. They can move in opposite directions, or they could have no visible pattern at all. Now, what this looks like in a table, what it looks like in a graph, what it looks like in a real-world situation is kind of different. They could also have a pattern that doesn't make a straight line, but there's definitely a pattern, and we call that nonlinear. Okay, now, as some of y'all attempted to do on one of our worst questions on the benchmark test, I'm sorry, the beginning of your, whatever that thing was called, y'all like connected, we don't connect the dots, guys, okay? Like when you look at a scatter plot, y'all said it was nonlinear. I totally get that. You said it was nonlinear because you connected the dots and they didn't make a straight line. But when it's bivariate data, the dots, we use them for a pattern. We don't connect the dots. We just look to see what the kind of in general what's happening. So remember how at the beginning of the year I told you we don't draw jankety lines. We kind of do little bit jankety lines with scatter plots. Okay, so let's go back up here. We never connect the dots on a scatter plot though. Okay, so again, bivariate data is when we look at two variables and how they relate to each other. We have four possible relationships. We have a positive linear right now we have four possible relationships. We have a positive linear, we have a negative linear, we have no correlation, and a nonlinear correlation. In a second here, we're going to talk about what that looks like. Now, that stuff is kind of like 7th grade stuff, but it's 8th grade stuff, but you learned it in 7th grade. Sorry, but you have to understand it in order to be able to do the algebra stuff. This is 100% algebra stuff. Okay, so let's talk about this. The statement is correlation or causation, okay? So correlation means that these two things are related. And I want to zoom in, but like I can't figure out how to do that. So like maybe there's a button, I don't know, or maybe, oh, that's not it. Oh, okay, I could just do that. Oh my God, now we got to try and focus. Okay. Oh no. I'm sorry y'all are having to experience this, but this is where we are now. Okay, so a correlation means that two things are related, and my handwriting is going to be extra special hard to read because I haven't written in a few days. I've just been laying on the couch groaning. So yeah. So correlation means two things are related. So like, how I smell based on how long I haven't taken a bath, or anyway, there's all kinds of things I could say right now, and most of them are about me feeling like poo-poo. So, like, you know, how many carrots I eat and my vision, or how big the tree is in the backyard, and how much rain we've gotten, how, you know, how long my hair is versus how long it's been since I got my hair cut. So those are two things that are related. Now, when we talk about causation, we say that one caused the other. Okay, so when we say that one caused the other, we're saying that those two things, not only are they related, because if they give me a graph, so like, let me give you an example of what I mean by this. I'm going to just scoot a couple of pages. Maybe I don't have one that says that. I don't think I put that one down. There was one that we used to have where they talked about like ice cream sales and temperature outside. Okay, so like when it's hot outside, so let's see, ice cream sales and temperature. Okay. Oh no, it wasn't ice cream sales and temperature. I'm sorry, you guys. I'm kind of like I'm like reliving. I'm relearning this as I go. It was ice cream sales and sunglass sales. But we can actually compare the two. So like, let's say we have ice cream sales and sunglass sales, and then let's say we're also comparing ice cream sales and temperature. Okay. Now, ice cream sales and temperature, are they related? I mean, you might think, well, yeah, people buy more ice cream when it gets hotter. So yeah, there's definitely a relationship there. But the question is, when it's hotter outside, do I have to buy ice cream? If I don't have to, then it's not causation. So, do I have to? That is the question when we're trying to decide if something is correlation or causation. It's, do I have to? So, as ice cream sales increase, sunglass sales increase. Does this mean that if I'm buying ice cream, I also got to go buy sunglasses? No, it does not. Does this mean that, so if ice cream sales increase as temperature increases, does that mean as ice cream sales, as the temperature goes up, I have to buy ice cream? No, maybe I like cold drinks, you know. This is, you know, also that, you know, like they talk about how like coffee sales go up and like hot chocolate sales go up when it gets cold outside. But I don't have to buy hot chocolate when it's cold. Maybe I want to. Maybe I drink coffee. Maybe I like Coke all the time, as you guys have figured out about me. Okay, so like there's a relationship, but there's not cause. Okay, so I want you guys to take a minute. I'm going to pause the video. I want you to pause the video. I'm going to pause. Well, I'm not going to pause. I'm just going to count to 5. Y'all pause it, and I want you to try these 4 out and see what you think they are. I'm going to cough and then count to 5, 4, 3, 2, 1. I assume you paused at this point, and if you didn't, I don't know what to say about that. Okay, so let's look at this one. The number of hours worked and the amount of the paycheck. So if I work more hours, does that mean I have to get paid more? Yes, if I'm working more hours and I'm an hourly employee, yeah, I have to get paid more. This is causation, because working more hours causes me to get a higher paycheck. Okay, the age of a child and his shoe size. Okay. That means as a child gets bigger, their shoe size gets smaller. I want you to just pause real quick and have a conversation about this, because I'm going to be honest with you, I would actually accept either one based on how you explain it to me. Go ahead and take 5 seconds. It'll take however long you need. Pause. Okay, so if you say like a child, right? So how long is someone a child? Okay. For real, a child's a child until maybe, let's say, 18. Some of us would say longer, but whatever. Yeah, eventually your shoe kind of stops growing. So it may not be like a linear relationship, but maybe that looks like, you know, your feet get really big faster and then they kind of level off like that. In that case, yeah, I can see a relationship between your age and your shoe size. Okay, so yes, I would say yes to correlation. But if you say, if your thinking was, well, no, I don't think it has to be correlation. well, that was causation. I'm sorry, y'all. I got the Rona. Just write causation. Yeah. Okay, so causation. If you're saying it's causation, then you're saying, yeah, as a kid gets older, their shoe sizes are going to get bigger. Now, if you're saying it's correlation, maybe your thinking for saying it's correlation is, well, except here's the thing. This does not mean, there's not like a direct link between their shoe sizes. Now, if we're talking about the increase in their shoe sizes, then yeah, but if we're talking about their actual shoe sizes, because like me in particular, Mrs. Deal, I have size 10.5 feet, and like girls back me up. That's a huge foot for a girl. That's a pretty large foot. There's only about like 5 styles of shoes at that point. But for a guy, that's not necessarily a big foot. For a girl, it's a pretty big foot. Now, I've had that foot since I was like 11. My feet have been big since I was 11 years old, this big. I've had giant feet that keep me from falling over, so go them. But yeah, I had big feet. So does that mean everybody had big feet, that same size feet at that same time? No. So this one, there's some room for discussion. But what about this one? The number on cold days and the amount of hot chocolate sold. On a cold day, do I have to buy hot chocolate? No, this one's causation. I'm saying correlation. Okay, because I don't have to buy hot chocolate on a cold day. Now, the number of miles driven and the amount of gas used. If I drive more miles, am I gonna have to buy more gas? Yes, this is causation. So again, do I have to is the phrase that you're going to use for correlation and causation. You will see one causation question on your test on Wednesday. Remember the phrase, do I have to? Okay? All right. So now let's talk about, we talked over here about these 4 relationships. Okay, so now let's talk about what they look like. Okay, so first of all, we have our positive correlation or our positive association over here. All right, when we talk about a positive correlation or a positive association, when we look at a graph, we're going to generally see the line for, this is a linear, so let's make that linear positive. A linear positive correlation is generally going to go up in a straight line. Up and right. So like just like a positive slope, a linear positive correlation goes up and right. And it generally makes a straight line. Now, is this a perfect straight line? No, but we don't connect the dots, right? See, because it says so right there, we never connect the dots. So yes, I get it, that's not a straight line. But if I kind of squished all those points together, that's about like where they would line up. And in general, it looks like a line going up. Okay, so that's what it looks like in a graph. A line going, looks like positive slope. Okay, now in a table, what it looks like is if I have all of my x's lined up, so all of my x's has to be ordered from least to greatest, or greatest to least, I don't care. Okay, so least to greatest or greatest to least, it doesn't matter. If I look at my x's are increasing. Okay, they're getting bigger. What's happening to my y's that go with them? They're also getting bigger. Okay, so as my x's increase, my y's are increasing too. That means I have a positive correlation. Now, I want to show you this. Let's take a look at this real quick. I should have done this for you too. So let's say I have 8, 7, 6, 2, 2. All right, 1. Okay, so maybe that's my table of data. And then I've got like 15, 14, 11, 9, 6, 6. Okay, what are my x's doing here? Are they increasing or decreasing? They're decreasing. What are my y's doing? My y's are also decreasing. So notice if they're both going up or they're both going down, I have a positive correlation. And the reason for that is what happens is if I graph this, so like if I were to graph these points, if I graph 1, 5, it doesn't matter if the 1, 5 is at the top or at the bottom. It doesn't matter which way they're going. When I graph those, they're going to look like this. If the x and y values are going in the same direction, it's going to be a positive correlation. So think about it like when you multiply. If it's the same sign and I multiply, it's positive. So if they're both going up, it's positive. If they're both going down, it's positive. So like, I've said too much. Okay, so if they're going in the same direction, so this means same direction. okay, if they're going in the same direction for the table, it's a linear positive correlation. Okay, now, if I look at a statement, the number of hours you work and the amount you earn. If I work more hours, I'm going to earn more money. Okay? Now, likewise, let's think about this. If I work less hours, what am I going to do? I'm also going to earn less money. Both a positive correlation because they're moving together. Okay, what about this one? If I burn less calories, does that mean I walked more or less hours? Probably walked less hours. They're both going in the same direction. Now, if I burn more calories, I walked more hours. They're going in the same direction. That means I have a positive correlation, positive association. Okay? And if it makes a straight line, it's linear. Okay? So that's a positive correlation. All right? Pause for a second if you need to. Talk to your table group. Make sure you got this on lock. And then let's talk about negative correlations. Okay? So a linear negative correlation is when, in general, I have a straight line going downhill. Okay, and again, it looks like negative slope. Again, if you sign the line, I'm going downhill. Okay, now, and again, it's not a perfectly straight line, but it mostly looks like a straight line going downhill. And when I say mostly, I'm talking like this. Like, look, that's not a straight line. That's a roller coaster. That's a slide. Okay, that's a water slide. I'm gonna go to a water slide. Anyway, okay, so it's generally going downhill. Now, when I look at a negative association on a table, what's happening to my x values? They're getting, in this case, they're getting smaller. But what's happening to my y values? They are increasing. They're getting bigger. So that means they're going in opposite directions. I forgot how to spell there. Y'all, I forgot how to math earlier today. I don't want to talk about it. Hopefully that'll all come back before I get back to y'all. Okay, anyway, opposite directions. Now, same thing happens in situations. So when there are more foxes in the area, what happens to the bunnies? What do the foxes do? They eat the bunnies, so there's less bunnies. Now, likewise, if there were less foxes in the area, what would happen to the bunnies? There'd be more bunnies, okay? Now, with the smallpox vaccine, which I know y'all don't even know what smallpox is. I never had to experience that. But when there was, as smallpox vaccine availability increased, smallpox deaths decreased. So you notice how these are all going in opposite directions. So they're not moving together, okay? And when that happens, that's when I know that I've got a linear negative correlation. Okay, so now let's look at the two that aren't linear, all right? So we've got this guy here, no correlation, okay? So like basically, here's what no correlation is. Dots everywhere. Like you couldn't make a line, you couldn't make a line through that if you tried. Like, I mean, you have to connect the dots. Like, is it going up? Is it going down? There's no pattern there. Like, here's what it is. I don't know what that is. It's all over the place. Okay, I can't make a pattern. So there's no pattern. Now, if I look at this, my x's are all increasing. So as my x's increase, look at this. It's going down and then up and then down and then it goes up and then it goes down, then it goes up and then it goes down. It's all over the place. It's just like there's no pattern. So the x's are in order, but the y's are all over the place. There's still no pattern in the y's. Okay, so there's like no pattern. And then look at this. Okay, the number of pasta dishes eaten and the number of cars on Highway 290. There may be, like, what? That doesn't make any sense, right? Like, as I increase more pasta dishes, as I eat more pasta dishes, like, do I cause there to be more? No, like, what? That doesn't even, if you go, huh? Like, if you kind of make, like, stinky face and go, what? That's telling you, no. All right? So, let's just put stinky face. Which I'm not going to be able to make for a long time because I can't smell anything. So that's going to be cool. We're going to have to talk about that. Okay, so the last one is a linear correlation, a nonlinear correlation. And you're only responsible for identifying this from a graph. So like, here's what you're going to do. You're going to kind of just generally draw a pattern. And if it's not a straight line, I mean, now you see though, but you can see that there is a pattern there, right? You can see like what I drew is the pattern of that line, but it's not a straight line. Okay? This one didn't have a pattern. This one has a pattern, but it's not a straight line. So it has a pattern. It's just not a straight line. Okay? So that's what it means when we talk about a nonlinear correlation. Okay? So for today, that's all you need to do. You're going to have a quiz on this tomorrow. It should be pretty easy. Okay? This is going to be a big part of your test that you're going to take, your mini test that you're going to take on Wednesday. You have 25 minutes for it. You have homework tonight. You need to make sure you do it. Okay? I miss y'all. See you soon.